All right, well, it's about time to start. So thanks for joining me, everybody. My name is Robert Douglas. I am the Chief Developer Relationships Officer at Platform SH, which means that I spend a lot of time talking to developers about the benefits of running applications in the cloud using a platform as a service like Platform SH. And today, I'm going to be talking about how you prepare for running thousands of websites. That's not a really common task. Who even has 1,000 websites? It's not like you walk down the street every day and just meet people who manage thousands of websites. That's a really special use case. But in our experience, there are organizations that run into this problem. So, for example, universities are one of the classic examples of an organization that would have sometimes thousands of websites. We are doing a case study with the University of Missouri, for example, 30,000 students per year, and the IT department there manages 2,000 websites. How does that come about? That's because in a university setting, usually every school, every department, sometimes even individual classes or projects or student groups, each one of them might have their own website to run, and they have a really interesting set of requirements. They need to be able to give the students running those websites enough freedom to do cool things with them and be creative and apply the knowledge that they're learning, while also making sure that the IT stays in control of everything going on. So universities are usually fun because you find a very interesting friction between the need to extend control and creativity to the people building the websites versus the desire to centralize IT and take control of things to reduce risk and complexity and the typical concerns. A lot of consumer brands that operate internationally also run into situations where they might have thousands of websites. There are many companies on earth that make consumer brands of various natures. For example, we work with a specific life science company that runs a very large fleet of websites. And for every product that they produce, then they will have that product in different countries, in different languages, and oftentimes, since it's life sciences, then they're regulated industries that they're in, and they have a lot of complexity around the way that they can talk to people on their websites, their data security models on those websites. And they also have, of course, the interesting challenge of maintaining their brand as they operate websites in many different territories, languages, where branding will have different subtleties. Sometimes brand names change when you change countries, which also would then change the packaging, the language, and everything, but they still have to be maintained centrally. Another interesting type of company that fits that model very closely is a consumer packaged good company who we also work with, also have hundreds of brands, and they have dozens of localized sites per brand. And they also, since they're less regulated, might have an e-commerce component. And they do very aggressive digital marketing because their marketing's less regulated or not regulated compared to the life sciences. And they'll make specific relationships with web agencies in different territories to manage and work on those sites for those brands. So think about that. If they've got thousands of websites around the world, they'll be working with hundreds of digital web agencies at any given time to manage all of those websites, and it's an enormous challenge. So that's the type of customer that has thousands of websites. Another one that I could add to that mix are governments. Oftentimes, like state or national legislators will have thousands of websites, or departments of education or departments of commerce will have thousands of websites because they'll have websites in every jurisdiction, or They'll have websites for every politician. Government websites also tend to proliferate quite fast. So those are the people who have thousands of websites. And if you have thousands of websites, after this webinar, we'd love to talk to you about how you're managing those websites. And if the challenges that I'm about to present ring a bell and are true for you as well, then yeah, let's talk about that. All right, so this is a checklist. It's a fairly thorough checklist. I'm going to try and keep it quick and interesting, but these are the topics we're going to cover, and it'll be the same pattern for every one of them. Development process, coding standards, code deployment, infrastructure, updates and maintenance, data access, and monitoring. Those are the topics, and for each one, I'm going to present some of the challenges and work up in order of worst practice to best practice with a celebratory GIF at the end of every one of those so you can see which one the best practice is. You'll see the pattern pretty quickly. So let's start. Development process. What's your checklist in the development process title? Okay, there are 3 subtopics: the onboarding and offboarding of developers, working with developer environments, and also stakeholder engagement. So when you're onboarding and offboarding developers, 1 star, worst way you can do it that I know of would be to make them install runtimes and services themselves. All right, developers shouldn't be doing that. Or give them root access to production. You should never do that. But I've seen that done because it seems convenient if you don't have DevOps and tooling to provide options for that. If you have your developers download code, keyword download, like click a link and get a tarball in a web app or FTP, that's 1 star. And if your developers are able to develop on all of your thousands of sites, pretty much nobody should ever be able to develop on thousands of sites. So these are all 1 star practices. Building up from that, if you have set it up so that there's a shared development server, if you check out your code from Subversion instead of downloading it, and if they have to be added to each site manually or in groups, then that's 2 stars. Building up from that, 3 stars. If you provide Docker images, love Docker images. If you provide a dedicated development server for each developer, a server of one's own. If you give them Jira access for triggering deployment, they close a ticket, it deploys. If they run a Jenkins task to get added to groups of sites that they can develop on instead of doing it one by one, then you're getting 3 stars. Now, here is our first 4-star checklist for running thousands of sites, onboarding and offboarding developers. If you add them to the GitHub or GitLab organization that you're in or team, and by doing such, they gain access to all of the sites and code that they need, that's great. If they can clone production to their local environment to work on, including the data and the services, be it by whatever mechanism, that's already a 4-star experience. And if they get a development environment for every branch in Git so that they can test their changes independent of each other, so that I can be working on 2 or 3 features, test those independently, you can be working on features, test those independently, and then use Git to do the merging, that's 4 stars. And if you can control which sites they can develop on by adding them to the right team, say in GitHub or GitLab, that is 4 stars. So that's the format checklist, and I'll speed it up so that we don't spend too long on each one. Let's keep going. Developer environments. Developers who just use whatever is working on their laptop, their PHP version or the Python version that comes with their operating system. Nobody knows if the versions are the same or if the configs are the same. They share a staging server. There's one shared staging server where everybody dumps their code for testing. You're going to run into problems. And if you use the same development environment and configuration for all of the sites that you're working on, these are all recipes for disaster. 1 star. 2 stars, Vagrant or similar solutions for local. Ops manually building cloud environments for the team. If you have to open a ticket to get an environment, then that's 2 stars. Vagrant's better than nothing, but it's not very modern. 3 stars, if somebody's in your organization building and providing Docker containers that you can then get from a registry and run locally. And if those same Docker containers can run in a container grid like Kubernetes, and if you're using different Docker containers for each site and keeping those separate, all right, I'm going to give you 3 stars for that. Up to 4 stars, though, you're going to want to use a fully automated development environment system like Lando, and that would reproduce the cloud environment that you'll be hosting on locally for your developers so that you have feature parity and system parity and version parity between cloud and local. If you get a copy of the production infrastructure for every testing operation with the exact services, configuration, and data. So if I want to do regression testing or integration testing on my new changes, and I can do that on an exact copy of the website. And if I can quickly switch locally or in the cloud between distinct environments for each of the 1,000 sites. Okay, so I'm testing one site, I am in one environment, but it's a completely different isolated environment for another site. That's the 4-star developer environment experience. And that's when you get to dance in the elevator. So just a note about Platform SH and Lando. We have an announcement that you might have seen on our blog. We are in a partnership with Lando for local development environments, and we will be able to do things like pull a project from Platform SH into the local Lando environment, pull and push all of the application components, so the code, the databases, the files, between the two, run Platform SH build and deploy hooks, create a new Platform SH project from a local Lando project, and you'll be able to do that for WordPress, Drupal, Magento, Easy, and Node.js projects out of the box with support from MariaDB, MySQL, PostgreSQL, Redis, Elasticsearch, Memcached, Solr, MongoDB, and Varnish. So that's a really exciting partnership, and we'll be expanding the stacks and the apps and the services that we can support through time. So check that out. Moving on to the checklist, stakeholder engagement. Okay, this is how you interact as a developer with the people who care about what you develop. Maybe the people who are hiring you, maybe the people that you're working with in your team, but the designers, the brand owners, those are your stakeholders. So if you're showing your stakeholders on your production site the product of your work, then you get 1 star. They need to be involved earlier in the process. If you're showing your stakeholders on the shared staging server, then you run the risk of showing them things that are half-baked or possibly broken because you're sharing that staging server with people who are doing other changes that you might not have control of. 4 stars. You send the client a URL that demonstrates a specific feature on a specific site. They click the URL and they're seeing that on a dedicated environment just for that feature. And if they sign off on it, you can merge it. If they give you feedback, you can continue working right there. And have URLs to send for every feature, for every developer in isolation, and have URLs to send for every feature for every site. So that's a lot of atomic encapsulation, so every feature, every developer, every branch, but that's great because that allows your stakeholders to present their feedback quickly and your developers don't fall out of their context, their brain space. So if you've been a developer before, you know that working on a feature takes a lot of internal mental preparation and setup. You've got to really think into a problem usually and understand the desires of the stakeholder and all of the problems that arise with the solution, and you make decisions and you put that into code. If you have to wait a long time for feedback, for the feedback cycle, then you lose that context. You fall out of the zone. If you get quick feedback on that, you've got the context still in your brain, you understand all those decisions, and you can then iterate on the feedback very quickly. If you have to wait 2 weeks, then you've lost it all and you've got to get back into it, and it just slows the whole thing down. So being able to do it that atomically is absolutely critical for a fast and efficient development workflow. So next big section, coding standards. Quality starts with the first line of code, and specifically third-party libraries, code quality, and testing. When it comes to third-party libraries, if your developers are downloading libraries directly into the code base, that's 1 star. If you're using a build system like Composer, NPM, pip, and you check the artifacts of your build into Git, so I run Composer install or NPM install, and then check that into Git, that's already up to 3 stars. The problem with that is that the way that I run NPM install on my machine might be different than the way your machine does it, depending on if our versions are the same, if our environments are set up the same, and that's why this is only 3 stars. However, if the developers check in the package JSON or the Composer JSON, the POM XML into Git, and the system applies a unified build pipeline across all developer projects so that every developer's code changes are always being built by the package managers the same way, then you get 4 stars and you are cooking code like a Swedish chef. In terms of code quality, you only get 1 star if anything goes and if the application works, code gets deployed. So this is actually the modus operandi for a lot of projects that start. If it works, it gets deployed, but there's a lot of room for improvement on that paradigm. We're going to shoot right up to 4 stars if your unit testing can block a deploy. Okay, well, that implies that you have unit testing and that you have a deploy process. If your code linting can block a deploy, if the use of blacklisted code can block a deploy, then those are 4-star qualities. If you have hooks that exist to trigger regression testing, integration testing, performance testing, and if that's done, of course, on the production code, but in a controlled test environment that's the same as production environment, these are 4-star qualities. All right, moving on, code deployment. Deployment methodology, speed and frequency of deployment, interruptions caused by deployment, deploying to a fleet, because deploying to 1,000 websites is in fact different than just deploying 1 website, and rolling back deployments. So for deployment methodology, if you're using SFTP, USB sticks, or if you're overwriting existing code when you deploy, 1 star for you. And always at this moment, I have to stop and tell a true story. I know an agency not so far away from where I live that has a customer who is a bank, and that bank is maybe a little bit backwards and old-fashioned in their deployment methodology. This agency, when they have an update to the website that this bank runs, they take a taxi from the agency's office over to the bank's central IT offices, which are, somewhere else in the city that they live in, and they hand the bank, the doorman, the person at the guard at the door, they hand him a hard drive, and they stand and wait as he takes that in and takes it to the IT department and hands it to them, and they do the deploy and the upgrade, maybe on a test server, I don't know, and come back to report whether there are any problems, because they're not allowed to go into the IT section of the bank or access any part of it over the network. So that's an interesting challenge in your deployment methodology. I'm not sure how many stars I would have to give them, but fortunately, they don't have 1,000 sites to upgrade at once. You get 2 stars if you SSH into your server and say git fetch, git pull, git checkout, whatever. You use the git command on the server to fetch the code that you want to deploy. That has some nice advantages. You can trust Git in a lot of cases, but I don't know. You don't really want to run into a merge conflict in the moment you're trying to deploy. And you should never really have to SSH into your server at that moment anyway. Plus, that would only take care of your code. A real good deployment methodology would take care of not only your code, but all of your infrastructure and your data all in one go. So 4 stars is when a git push to a remote triggers deployment to a test environment, and a git merge triggers the deployment to production after the tests have passed. The old environment is not updated, but replaced. And this is something that containerization has made possible in recent years, and that's super important. It used to be that you would upgrade your server, like you just fix it in place, like you deploy new code onto the server. You've got a website on there, so you deploy new code. That's the new version of the site. It's time for a MySQL or a PostgreSQL database upgrade. You stop the website, you upgrade the server with apt-get install, and boom, bring it back online. So that's not the way to do it anymore. The way to do it is to let your website run on a deployed version of it and completely build the new version of the website with the code or the infrastructure changes or anything that you want to fix or change, new services, maybe you're adding Elasticsearch, whatever, on new infrastructure. And when it's ready, you detach the data from the running servers, and you put it on the new servers and redirect traffic in a coordinated way. And that's the best practice these days for upgrading your infrastructure or doing major website upgrades. So that's 4 stars on deployment methodology. In terms of the speed and frequency of deployment, I've seen we update the site twice a year. Literally, that when I started in web content management, that was actually pretty common. Those were older systems like Red Dot was one of them that I heard that from a Red Dot customer. Yeah, we deploy the new site twice a year. 2 stars is maybe deployment at the end of each sprint, typical sprints being 2 to 3 weeks. So not so frequently, but much more than twice a year. 4 stars, we deploy every day, many times as soon as a feature passes testing. That's a quote from an actual customer, and it's true. They're a newspaper and they deploy continuously. Anytime if a developer's feature passes all of the testing, it goes straight into production. And they do that even when the site is under load, which for e-commerce could mean even on a Black Friday, where the load is obviously the highest and the stakes are the highest. Deploying on Black Friday might be considered taboo if you don't have utter confidence in the speed and dependability of your deployment methodology. What about the interruption caused by a deployment? Well, back to my a couple of my previous examples. If you have to do a lot of stuff on the running server, like update your tables, upgrade versions of running software, then you have a moment when the site could potentially be inconsistent. So the old-fashioned way is to put the site in offline mode. So Drupal, for example, even has a feature called offline mode that you can do while you're deploying, because it's recognized that it's simply unsafe to keep running the site if it's in an inconsistent state. But that's really 1 star. Let's jump to 3 stars. If you freeze the incoming requests during their critical phase when the database schemas are being updated and the infrastructure is being updated, and you throw a CDN on that for the static stuff so that your website visitors at least get a partial experience of the site and it's brief, maybe they have to wait for those frozen requests, 30 seconds or a minute, but they go through when the upgrade's done. Okay, that's a pretty good experience. That's 3 stars. And that, in fact, is very similar to what a lot of Platform SH customers do and experience. Gee, Rob, why did you only give that 3 stars if that's what your company does? Well, because there is, of course, something better than that, but it's hard. It's hard to do because of the nature of web apps, and you can solve that problem on Platform SH as well, but your application has to be built for it at some level. And I think this is, in fact, part of the reason why a lot of people are using static site generators and Jamstack, because then part of their infrastructure can be upgraded and deployed with 0 downtime, which is otherwise pretty hard, although that's not a silver bullet for that problem either. But the 4-star deployment is the customers never notice that you deploy no matter what, and there's no downtime. That's a whole topic of its own. This is an aspiration. This isn't a recipe for doing that, but that's definitely the holy grail for everybody who's ever had to upgrade complicated websites. So how do you deploy to a fleet? Well, 1 star is what you get if you deploy to each site one at a time, because guess what? You've got 1,000 sites, and that's going to take a heck of a long time. 2 stars if you do some sort of like multi-site. Okay, take Drupal as an example here. You deploy code, then you have each database run sequentially to update each database. And if you've got 1,000 sites, you just update 1,000 sites sequentially. This is exactly the strategy that Acquia Cloud Site Factory takes. And well, that's a 2-star approach. Definitely better than 1 star. 3 stars, if you don't use multi-site, you have all of your sites running independently of each other, and you have some sort of automation that knows where they all are and can automate those steps. So you take like a Jenkins task. It says for every site that we have, go and do this upgrade because the database scheme has changed and we update that, update those sites. 4 stars, and this is really a very important different concept. So with the Jenkins, this previous one, Jenkins calls out to those sites and says, hey, upgrade yourself. And it has to do that 1,000 times. The 4-star approach, however, is that sites pull their updates automatically as soon as one's available, and runs their updates automatically. So the site itself is in control. And we do this on Platform SH using something called source operations. And it's actually one of the central planks in, excuse me. It's one of the central planks in the fleet management tooling that we're building, because it basically gives the site the ability to write its own update when it's available from a central source. And then site owners are able to update that upstream central source and know that those sites are subscribed to its changes. And the sites that are subscribed to its changes will simply update themselves. And the subscription model there is important in making it less critical to maintain a centralized list of all of the sites that need to be updated. Because it's easier to know from the perspective of one site whether or not it needs to be upgraded or updated based on the newly available upstream version. It's easier to know that than it is to be the owner of the upstream version and have a list of all the sites that need to be upgraded as a result. So it's an inversion of control to have the sites do that with source operations themselves. And in that way, you can have target groups of sites for updates. So if you publish new functionality, then it doesn't have to automatically upgrade all the sites. There are a couple cases for this, like if you want to do a small percentage of your sites and see that your changes are going to hold up in production as well as you think they are before you roll it out to all of them. Or maybe it's a functionality that only applies to a certain number of them. For example, all of the sites that use a specific payment gateway, or all of the sites that need to be GDPR compliant, something like that. All of the sites for a certain brand, some grouping that your organization has. And it's very important as well that if this process is going to scale, when you deploy to a fleet, that they all have to be independent and parallel. So you can trigger all of them to upgrade it at once, but they do it independently. If one fails, it doesn't stop the process for the rest of them. And they can do it in parallel, not sequentially, because you don't want your wait time and the deployment time to scale linearly with the number of sites you have. Otherwise, every new site that you add is more complexity, and you'll start having an incentive not to have more sites. And if you already have thousands of sites, then there's probably a good business case for having that many sites, and you don't want to get in an arguing situation with your business and stakeholders about whether or not somebody really needs another site or not. So keep it parallel and independent when you do the deployments. So anytime you deploy, it could be that it goes wrong, or that you discover only sometime later that it's gone wrong in a way that you didn't know at the time. And then you need to roll back. So you get 1 star in this category if once you deploy, the old site is simply gone, vanished, gone away, not available. Only the new site remains. That would happen if you, for example, deploy all code changes using FTP or SFTP, and you've got the old code on the server and you replace it with the new code over SFTP, and then you realize that it's gone. Then you need to go and restore backup. Okay, that's the situation when updating the server is a one-way street. Okay, once you've updated the server, you're stuck with it. The 2-star version of that is assumes that you have backups and that you can deploy the backup. That's pretty easy and okay to do for the code, but if you're doing infrastructure upgrades and you're like upgrading your kernel version, if you're upgrading your PHP version, if you're upgrading your Elasticsearch version, then it's usually like on a virtual private server or something like that, or AWS, you could find that that's much more of a one-way street. Once you've upgraded those versions of your infrastructure, it might be really hard for you to roll this back effectively. Lots of work. So a backup in that case doesn't really help you very much. 3 stars, you keep the old deployment around, example given like a symlink or a separate server, in case you're not happy with the deployment. You can just switch back to the old one. And you use the DNS or load balancer to direct traffic. This is maybe one of the underlying premises of the blue-green deployment strategy. So the idea here is that you deploy your new changes, infrastructure and code, to new infrastructure while keeping the old site running, and then either suddenly or progressively direct the traffic from the old to the new. And if it goes wrong, your rollback strategy is to, at the DNS or load balancer level, go back to the old one and just redirect traffic. There are too many disadvantages to that to get into, but it is hard to coordinate, hard to automate, and you can't really trust data consistency in particular in the situation. You can easily run into situations where the new code violates the data model of the old code, and once you've switched to it, it's got to be permanent. 4 stars in rolling back deployments comes from when your code base specifies not only the application, but the infrastructure as well. And this is a very important concept at Platform SH. Your infrastructure definition is done in your code base alongside your application code in very simple YAML text files. So the services that you run, the MySQL, the Redis, the Elasticsearch, etc., as well as the disk space you need, the versions of your runtimes, Node.js runtime, Java runtime, PHP runtime, all of that is specified in your code base in these text files, configuration files. That means when you check them into Git, that triggers a build and a deploy that has those services and software versions and dependencies in it. And therefore, if you roll back to a different Git branch and deploy, or a different Git commit, a previous commit, because you detect a mistake, then not only do you perfectly roll back your code, but you also roll back the infrastructure so that the infrastructure can go both forwards and backwards as easily as you merge or revert Git commits. And as for the data layer, then you're getting 4 stars if perfectly consistent snapshots are taken before deployment and they can be easily restored. So then the workflow becomes make a data snapshot, do the deploy, detect a breakage, do a git revert so that your code and infrastructure are to the previous version, and restore the snapshot. And then you're back to exactly where you were before things went wrong. All right, let's talk infrastructure. A lot of topics here. Let's get right into it. When it comes to infrastructure, the ease of provisioning is really important especially if you have 1,000 sites. Let's just suffice to say that if you've got a typical website that has a front end and a back end and some services, you could easily be responsible for provisioning a database, a queue, and a search server, and maybe some other things to do things like generate derivatives of your images, to process logs, to send emails. All these things need to be set up for every website. So this really needs to be easy if you want to scale to thousands. If you have to open ops tickets for new environments, hey, dear operations team, give me a new something, then you're at 1 star automatically. If you have to collect specifications from a lot of people and compile those specifications and maybe put those into that ops ticket, that's 1 star. Somehow it says older machines on the slide. It's supposed to say order machines. If you have to do capacity planning about your website in terms of making sure that you have enough servers available or virtual machines available, and especially if there's a purchasing decision around that, 1 star. If your ops team starts configuring machines and installing software the moment you tell them you need a new website, 1 star. If they have to extend you access in a handoff, then 1 star. These are all things that are going to prevent you from scaling to thousands. Step up from that is when you can provision as many VMs as you need, and you configure them with like Ansible and Puppet. Like, let's say if you had a cloud solution where your ops team goes in and starts some VMs and tells them to hook up to a Puppet master who will then configure those servers. And when Puppet master's done, then it triggers a signal to the ops team to tell whoever that their servers are ready. Yeah, 2 stars. If you can launch your Docker image into Kubernetes cloud, for example, just upload the image, and as soon as it's there, you can deploy it and scale it and run it. That's pretty good. I'm definitely going to give you 3 stars for that. And there are a lot of benefits to a system like that. 4 stars comes when you define the infrastructure and code, and infrastructure adapts automatically every time you do a git push. And the reason for that is that means that you can create a new project with 1 click and push code that you might have used for a different project that might be pretty much exactly the same, and you need just a new version of that old project. Then you can do that in seconds. All you have to do is create the new project, push the code, and all of a sudden you've got infrastructure and application running like on that previous project. And you've got a great starting point for your new project. And of course, in terms of provisioning and operating, if you've got a very easy or automatic way to scale that infrastructure so that you're not worried about your capacity, that's definitely an important benefit. In terms of versioning, I'm going to even skip the 1 star. Nobody these days would be foolish enough to do web development without some sort of code versioning. But this is infrastructure. Sorry, I got off track. So I think for me, it took a long time to even think to like come to the concept of versioning my infrastructure. Like, I would always have servers and stuff that I would maintain, and I'd keep them up to date. And I thought all you have to do is keep them up to date. But in fact, sometimes the code that you're deploying is really specific to the infrastructure underneath it, specific database versions, specific operating system packages and dependencies. And it then becomes super important to version your infrastructure. With versioning, then comes the ability to do the rollbacks, like I said. So once you've done 5 upgrades, if you needed to go back and test something, maybe for compliance reasons, on an exact version of the infrastructure at a certain moment in time, you need versioned infrastructure. If your infrastructure obeys a template like Ansible, Puppet, or Terraform, that's already, in terms of the versioning of the infrastructure, way better. So 3 stars on that. And therefore, the version of the infrastructure can be deduced from the template So you never have to ask the question, what version of my infrastructure is running, but you just look at the template and you know exactly, because that's what it's based on. That would be great too, because for when you have thousands of sites, you need to audit them and you need to make sure that you know the infrastructure for all of them is running the right versions and up to date, and you're looking at risk models and security models. So quickly auditing those templates is a boon. 4 stars, however, is when infrastructure is strongly linked to a deployment. So your infrastructure changes the same way that your application changes, because infrastructure and code are together, and that your infrastructure basically comes from whatever triggers your deployment, which ideally is a git push. And that the versioning of the deployment, which results in a git hash for that commit, is thus the versioning of the infrastructure. So if you want to know what version your infrastructure has, you can name a git hash, a git commit, okay, an ID identifying specifically a git commit, and that's how you version your infrastructure. And the benefit of code plus infrastructure together is specifically that that same identifier is incidentally also the versioning of your code. Deployment parity, that is whether or not you're developing and deploying and running on the same type of infrastructure. So if the process of setting up a development environment differs from the process of setting up a production environment in any way, then you're screwed. 1 star. Developers are left to their own to get the software and services they need. You say, oh yeah, we're going to be running PostgreSQL, and they're off to the races to go to, install that. No good. If you provide container images, though, for your developers, and those are the container images that they use to develop and then deploy, and this is something you can do with Docker, Lando, to an extent Vagrant, 3 stars. 4 stars, happy cats. The same build process that builds and deploys production infrastructure also builds development environments for the cloud and local. With the Lando integration, we get very close to 4 stars on Platform SH. There are still some differences. So we are probably at 3.5 stars on this, with our eye on getting to 4 stars in the future. But it should be, ideally, that the same mechanism, creating a new Git branch, for example, triggers both the deployment of a new infrastructure in the cloud and sets up your local environment for development with exact parity, meaning exact versions of all the software, exact copies of the data, so that you never, ever, ever run into the situation that something works on one environment but functions differently on another environment. All right, what about shared versus isolated infrastructure? All right, so when it comes to infrastructure, that's an expensive resource, and there's always a great motivation to get as much value out of that resource as possible, and thus an incentive to share anything that you procure, such as a server or disk drive space or bandwidth or CPUs, to share that with as many applications or people as possible so that you get the most value out of it. You don't want idle resources that you're paying for. So if you have server level access to multiple sites at once, that's bad, okay? And specifically, if you can like log into the server and change the website, that's really bad. If your sites share infrastructure and occupy the same user space, like with multi-site solutions, I'm thinking lots of e-commerce stuff like Magento, or Drupal does multi-site, WordPress has a multi-site, or if you have doc routes with no containerization, like a pattern that I've seen a lot in the industry is you've got a server, you've got these things called doc routes, which are different code bases, and your Apache or Nginx simply routes the requests to those virtual hosts, sometimes they're called. These have lots of disadvantages in terms of sharing versus isolating your sites. So the principal disadvantage is the noisy neighbor effect, where if one of those sites from those doc routes or vhosts gets attacked, it takes all the resources away from the server and from the other sites. So in the old days in shared hosting, I remember having a website where I could look at my root directory and see all of the directories from all of the other customers who were on that root server. I couldn't go into any of them because they were permission blocked for me, but I could see the folder names, the directory names, and thus I could see who those customers were and what websites they were running. And some of those websites were, either websites I didn't want to be associated with, or websites that could get a lot more traffic than me, thus take the server's resources away to my detriment. So all of those are trademarks of 1 star. Moving up from that 2 stars, you'd have your environments be segregated by permissions, but not physically, RAM, CPU. That's more like the example that I just gave with the old shared hosting and jail-rooted vhosts. 3 stars is containerization, where containers will provide guarantees around the access and the CPU and RAM segregation. Already a lot better. The 4-star variation is when you have dedicated infrastructure for each site. So every site would have its own servers, its own disks, its own network. The problem here is that you can't really do this very easily if your sites are small. So most organizations with thousands of sites will go between a containerization and possibly a dedicated infrastructure solution for their top tier sites. But just alone on the concept of being isolated, having dedicated infrastructure for one site is clearly the strongest level of isolation. All right, what about disaster recovery? So your site gets wiped out from a catastrophic disk drive failure, or your data center blows up or something like that. If you have to start from scratch, recreate the site somewhere new from like whatever the developer had on his laptop, or you've got different backups, for example, for your database, and you get your code from Git, and you've got your uploaded images in a tarball somewhere. You've got to mash all that together to get your site back. That's the 1-star solution. Up to 3 stars, if you can guarantee an exact copy of infrastructure in a new location, that's already great. And that's what you would get if you had a Dockerized Kubernetes type of infrastructure deployment, because then you could take the containers that you had from your registry and just run them in a different Kubernetes, and you'd know they're the same. Then if you can redeploy the code from Git, then you at least know the version of the code is the same. And if you have those backups and you can import the DB, you can move the files into place, that's great. But to get 4-star disaster recovery, and I have mixed feelings about this GIF, I have to say, that triggers a lot of ow stuff in me when I see Homer do that with a hammer, but okay, well, I hope it goes better for you. 4 stars is when there's an automatic replacement of failed infrastructure. That means that your orchestration layer, monitoring layer, detects infrastructure failures and simply replaces it without you knowing, which is what Platform SH does. If the data is portable, meaning it can detach from a failed service like a database and reattach to a new service automatically based on service discovery, so that the failed database server isn't an availability problem because you'll get a new database server and that data volume can just attach to that server automatically, that's 4 stars. If you need to do a data rollback, you can do it with an API call and you don't have to worry about where your backups are stored. Or if they're consistent between each other. Another problem with backups is that if you like back up the database and your images and your Solr index all separately, they can fall out of sync with each other. So you really need point in time consistency on your data backups. And you really want to be able to trigger those and roll those back with just an API call or a tool. And this same process should apply to 1 or 1,000 sites, because that data center blowing up could have taken out a lot of your fleet. And if you really want to be able to recover a lot of sites very quickly from a catastrophic event, it needs to be one process where you just choose the list of sites and move them to a different place and restore them all automatically. One of the problems that people run into in these situations is the underlying capacity guarantees, which is worrisome. Like if an Amazon region goes out, then the other regions sometimes take so much load with people trying to move their sites that they can't guarantee enough resource growth immediately. That's not been such a problem recently, seemingly, especially as the space for public clouds is, the competition is really hot with big 3 American cloud providers plus Chinese and European cloud providers also going for that space. So there's a lot of cloud capacity these days. All right, immutabilities, a big topic for your fleets. If you can change things on the server, 1 star. If Puppet or similar tools detects changes and reverts them, like I can go on the server and change things, but Puppet's going to put it back, that provides us a guarantee of state, but it's not ideal. The 4-star variation is that builds are permanent and can't be changed. They've got read-only file systems and they're disposable, meaning when you do a new build of something else, then you switch everything to that build and just throw the old build away. I kind of covered that previously. Infrastructure rollback, of course, we discussed that as well. If you revert to a previous Git commit and that reverts the infrastructure to the previous state as well, 4 stars. Updates and maintenance is the next topic. So I've got 3 topics in there. I'm going to go through them a little more quickly because we're coming up on the end of the hour and I still want to have some time for questions. So when you produce new versions of something, let's say a security release comes out for a component, if you're Equifax and you fail to patch your server and therefore lose millions and millions and millions of people's personal data, including credit card numbers and security, social security codes, if you're Equifax, you get 1 star. In fact, I would give you -1 stars. If you respond to security mailing lists to find out when your software needs to be updated, it's better than Equifax because they didn't even do that, but you're still getting 2 stars. Excuse me. If you're aware of code vulnerability monitoring tools like Tech Beacon, well, that's an article there that lists 13 of them. I'd show you, but we're out of time. But just Google for code vulnerability monitoring. There are lots of tools. Definitely already up to 3 stars. But if your upstream updates are automatically pulled and prepared for testing on a regular basis, that's the best situation of all, because in a complicated web application situation using open source components usually, then the world is always moving and there's always risk and threat being detected, and software packages will always have new releases, maybe very far down on the dependency chain. Monitoring all that's impossible, so you simply need to have a regular schedule whereby those get pulled in and built and tested automatically, and then you can throw the switch on whether they get deployed. When you have 1,000 sites, you really need to be able to audit your fleet. So you might have questions like, hey, out of all my sites, how many of them are running Drupal 8.6? How many sites are running the Views module? How many sites have an old version of React.js? If you have to ask those questions and go and count them individually, 1 star. If you can ask the site automatically about its versions and the infrastructure, maybe through Drupal console or by asking a script, then that's 3 stars. But if you really want to be able to audit your fleet, then make it easy on yourself. If you can, for example, look at your composer.lock file and then realize as a result of that, what packages you have installed. And if you have a tool that can parse all of them and you have the guarantee that what's in the composer lock file is what's on the site. Or if you want to know your server infrastructure, if you can just simply look at all your services.yaml files in your platform SH projects and therefore know all of the sites are running the same MySQL or Postgres versions, then that's going to be a 4-star experience. I'm going to skip that one. So when you push those updates, if you have to push them out individually, I already covered that a bit, that's 3 stars. But if the sites are self-updating and pull those updates, definitely 4 stars. All right, quickly through data. Want to talk a little bit about the backup consistency. Anything using zips, tars, rsyncs, or FTP is out. I'm guessing. Okay. Thanks, Catherine. With backup consistency, what we recommend is taking disk level snapshots. That means that the database, the uploaded files, anything that's persisted on disk is taken in a moment of time snapshot so that the consistency between them is perfect. The backup frequency and retention is also important. You want, if you can, to use incremental snapshots, which allow very granular rollbacks. So if your data is changed, in the last hour, you can go back an hour in time. If the retention is prescribed, if you need to be able to keep backups for a certain amount of time, and that's auditable, that's a 4-star experience. And different types of data may require different retention plans. And platform uses a technology called Ceph, keyword RBD snapshot, if you want to look at what we do under the hood for that to achieve those. The accessibility of the backups is also really important. I've seen backups where it's literally CD-ROMs in the CTO's office. I've seen backups where you have to download tarballs. I've seen snapshots that can be applied to a region, but if you needed to move it to a different region, that would be a challenge. And the ideal situation, of course, is that there are snapshots, but they're controlled by an API that is independently available to the sites that may or may not go down and need disaster recovery, and they're globally applicable. So using the same API, you could take a snapshot and launch it in a different place on the globe. That also has a lot to do with the return of operations. My question for anybody with any website, not just a fleet website, is have you actually tested your return to operations? Did you actually test that? Did you kill a site and practice putting it back together someplace else? Or did you just hope that that never happens? That's funny, I get to the 1 star there. In terms of access, when you've got that many sites, you're really going to want to have some structure to who has access to them. Remember the consumer goods products companies that have thousands of sites with different brands in different countries. For that, you need teams and organizations, and you need a specific level of authorization granularity. 4 stars for that is when you've got central authentication through one system, like an Active Directory, that then provides SSO across all the tools that your developers will need, no matter what organization they're actually in. You'll need to be able to know for whom is a given developer working, and what's our relationship with them, and can I control their access based on their organization or their group or their team. And that combination of organization plus team plus role determines the access permissions on 1 or 1,000 sites. Same with authentication granularity. You're going to want to have the differentiation between whether somebody's a stakeholder or a customer or a project manager, an auditor, a developer, an administrator. All of those people have different granularity of authentication and authorization on your project. And to be able to control those across 1,000 sites requires these things back here, the teams and organizations. Monitoring, these are fairly obvious to people that you need to monitor your sites, do HTTP checks on all of them, have a dashboard that shows it all. You need to also check your transactional processes. A lot of people forget to monitor their API endpoints as well. Those aren't visible websites, so they tend to be out of mind, but they need monitoring as well. And you want to do application monitoring. A lot of the ones that Platform SH supports are New Relic and Tideways, New Relic being obviously the most famous, but Tideways being really great for PHP in particular. And we also have a partnership with Blackfire.io, which is traditionally known as a profiling company, but they're moving into the APM, application monitoring space as well. So definitely worth checking them out. I've come to the end of my checklist, and I'll go to the conclusions because I know it's been a long webinar. Conclusions are: running 1,000 websites well is based on the same principles as running one website well, but every aspect of that has to scale. And when you have stricter rules and guardrails, for example, centralizing user management and restricting what can be deployed, that's necessary if you want to have a consistent and manageable fleet, but beware it also puts a burden on the developers and end users of those websites in their challenge of fulfilling their business goals and having the autonomy they need to do what they see necessary to fulfill their missions. You can only do this with automating everything and monitoring everything, and the scale of having thousands of websites can be overwhelming. So therefore, you have to be absolutely vigilant that no manual inefficiencies are creeping into that. So those are the conclusions. I'm going to go check out if we've got any questions from the audience, but before I do that, I just want to advertise that we're having another Fleet Ops webinar about the University of Missouri and how they cost-effectively migrated their fleet of web apps to the cloud. That'll be next Thursday, April 30th, and I hope you join us for that. And with that, I'm going to check into the chat. All right, I'm not seeing any questions. So with that, I'm going to say thank you everybody for coming and paying attention. And there will be a recording of this that you can share with others who might want to see it. And that's all from me. Have a great day.